Hopefully everybody can hear me. It's 1:45, so we can go ahead and start this session. Good afternoon, everyone. So welcome to session 3.2, After the Storm, Impacts of Climate-Related Disasters. So this topic couldn't be more timely or important right now, I think, with natural disasters like Hurricane Ida and the wildfires going on out west. These things are happening more and more. Due to climate change, natural disasters are becoming increasingly frequent and severe, which makes understanding their economic impacts and our ability to adapt to them all the more important. So today we've got three interesting presentations on these topics. The first is by Emily Gallagher of the University of Colorado at Boulder. The second is by Jonathan Colmer of the University of Virginia. And the third is by Alessandro Barattieri of the University of Quebec at Montreal. The presenters have 20 minutes each, followed by 5 minutes of Q&A. If you have questions for the presenters, please put them in the Q&A window. And at the end, I will try to verbalize those questions to the presenters. So let me go ahead and turn things over to Emily Gallagher for the first presentation. So go ahead, Emily.
Great, thank you for having me. So this paper is joint work with Steve Billings at Colorado as well as Lowell Ricketts at the St. Louis Fed. And basically in this paper, we explore the use of student debt in the aftermath of a natural disaster. And we're really focused on the use, meaning the ongoing taking out of student loans in order to finance continuing education. It's completely true that a natural disaster could affect people's ability to pay down old student loans, but that's not really our focus. It's about whether people are using more or less student debt in the aftermath of a disaster. As we all know here on this call, natural disasters have increased in frequency and severity. And there's been this growing literature in economics and finance that's linking climate change to investment decisions. So we have papers showing how, for example, sea level rise is affecting house prices on the coasts, how small business investment incentives change when they're exposed to disasters, and people's willingness to invest in risky financial assets. But to date, we really know very little about the impact of climate change and related disasters on investments in higher education. And this question is really relevant in the US because we have this heavy use of household leverage to finance higher education in the US. So in recent years, about 2/3 of college grads have finished with student loans. And in prior work in other settings like recessions, there's been this suggestive evidence that these kind of wealth shocks that affect housing wealth in particular tend to lead to a rise in student debt. So a natural implication here is this question of, will climate change worsen the student debt crisis that we already have going on in the US? Now, surprisingly, student debt hasn't really been examined before in the context of a natural disaster. One reason that might be the case is that student loan servicers didn't consistently report data to credit bureaus until about 2005. And most of the existing literature on the household financial response to these kind of disasters comes heavily from Hurricane Katrina, which hit New Orleans in 2005. So people didn't really have a chance to establish a pre-period in the context of Katrina. Still, we know some things about the household financial response to disasters because of Hurricane Katrina. So Gallagher and Hartley have a paper that showed the impact of Katrina on a range of credit outcomes, things like delinquencies and credit scores. We have this paper by McIntosh looking at the labor market consequences. And we have some evidence from income tax on how being flooded in Katrina affected people's later income tax. Now, the reason we're so interested in student debt is because the predicted effect of this kind of housing wealth shock is actually ambiguous on student debt. So on the one hand, natural disasters are going to act primarily through this loss of housing and property wealth. So to the extent that some households will borrow against these assets to help finance college, disaster-affected households may need to substitute more into student loans in order to keep up that same rate of human capital accumulation after the disaster. And so a loss of housing wealth should portend an increase in student loan borrowing. This is this idea of liquidity effects. So there is substantial evidence that home equity is used to pay for college. So these authors show that up to 22% of households extracted home equity to pay for college in this 1999 through 2013 period. And for every $1 of home equity that was lost during the Great Recession, households increased their student loan debt by 20 to 80 cents. At the same time, we know that home equity extraction tends to go up whenever mortgage rates are low. And at the time of Harvey, mortgage rates were low. They were just 3.8%. Compare that with federal Stafford student loans, which had rates of 4.45 for undergrads and 6% for graduate students. So all this means that home equity would have been an attractive form of college financing. And so if it's eliminated because your house floods, that should have pushed some Harvey victims to substitute into student debt in order to keep going to school. So under this kind of channel, we should expect more student debt in the aftermath of a disaster. But there are also reasons to think that the opposite might happen. So first off, education is both a consumption and an investment good. So if house values fall, we might get a drop in general consumption, taking courses for pleasure, for example, as well as investment, taking specific courses in order to achieve higher earnings later in life. And if you're not taking those courses, you don't need the student debt, right? There might also be a debt overhang mechanism. This is a concept from corporate finance. And it's the idea that you have this loss of housing wealth, which causes you to have more leverage, right? More debt relative to your assets. And a higher leverage ratio may cause some people to forego an economically efficient investment in getting certain education programs because any additional earnings that they would get later in life might just end up getting garnished by a foreclosing lender. Wage garnishment happens all the time around delinquent student loans. So under this kind of debt overhang mechanism, only education that is associated with a pretty high return on investment, a high NPV, will get funded. So think about high expected earnings majors. And there's substantial support for this idea of debt overhang in the context of student debt already. And part of the reason this might be such an important channel is that student debt is non-dischargeable in bankruptcy. You can't just get out of it later. The lender will come in and actually garnish your wages. And then finally, you have this concept of opportunity costs. So students may delay or forego college in order to take advantage of employment opportunities. So construction jobs, for example, that are created by the disaster. And if they do that, then they need less student debt. And then you could have a more informal mechanism here where families simply ask their kids to stay home and help them rebuild. And if they aren't going to school, then they don't need student loans. So even though evidence in other contexts like recessions would say that student debt should go up after this loss of housing wealth, there's still plenty of reason to think that it could go down. The predicted effect is ambiguous. It's an empirical question that we try and answer in this paper. A bit of background on Hurricane Harvey. So at the end of August of 2017, the Houston area experienced the largest amount of rainwater ever recorded in the US from a single storm. Harvey submerged over a quarter of Houston, caused $125 billion in damage, and only about $19 billion of that was insured. And scientists have estimated about half of that $125 billion could be attributed to climate change. Now, Houston flooded pretty much all over. So what this map is showing you is all the different parts of Houston that flooded. Those areas are in gray. And if we zoom in on this little part, you see a little square in the middle. If we zoom in on that little part and we overlay the 100-year flood map, that's what you're seeing in the corner there. You're seeing the 100-year flood map in red and the parts of Houston that flooded in gray. And what you can see is Harvey was kind of unique in that a large share of the flooding actually occurred outside the floodplain, and there are places inside the floodplain that did not flood. And so we can use that because we can compare people in flooded areas to not flooded areas that were both inside and separately outside the floodplain. And that is going to give us a sense of how flood insurance might have mitigated the situation, because mortgage lenders typically require that you have flood insurance if you're located within a 100-year floodplain. Now, it wasn't just Houston that flooded, so 40 counties severely flooded. Those are the ones there in red, kind of surrounding the Houston area. And another thing we're going to do in this paper is look at higher education outcomes at different Texas schools, those that drew more or fewer students from within that red area, that red set of counties highlighted there. So as I mentioned at the beginning, a lot of studies have come out of Hurricane Katrina, and Harvey was second in cost only to Katrina, which hit New Orleans back in 2005. And most of the literature came out of Katrina, but it's not necessarily the most representative of all disasters. So what I've plotted here is certain socio-demographic variables for large urban areas hit by hurricanes in recent years. And what we find is Katrina was really an outlier on nearly every dimension we tested, whereas Harvey is kind of near or inside the interquartile range along most measures. So measures like the population change after the disaster. Of course, Katrina was associated with a massive diaspora. Harvey wasn't. The change in unemployment rate after the disaster, the share of people who were exposed to the flooding and who had a college education, for example. In all cases, Harvey appears to be a much more representative disaster. So ideally, the results that I'm going to share with you today should presumably translate on at least in direction, maybe not magnitude, to other similar disasters in the US. Okay, moving on to some of the main results. So here we're looking at the use of student debt, and we're going to use a data set called the New York Fed Equifax Consumer Credit Panel. What this is a random 5% sample of all people who have a credit report in the US. We're going to find about 125,000 people with credit files and permanent addresses in Houston as of Q2 2017. So that's the last quarter in before Harvey hit in Q3 2017. Of that 125,000, about 7,000 were college-aged adults, meaning aged 18 through 26. And these are people who have permanent addresses in Houston. So maybe they're living at their college, but usually for your FAFSA form, for your credit card applications, all these things, they generally ask that you use your parents' address, your permanent address, as your permanent address. And so in most cases, the sort of financial effect of flooding should be properly assigned. We're going to merge this credit data in at the census block level. It's pretty granular with FEMA flood map information. And we're going to run what's called a treatment intensity difference in difference, where our treatment is the weighted average flood depth across the developed portion of the individual census block. So the depth as well as the breadth of flooding should be captured in this measure. And it's going to be assigned to individuals according to the block where that individual had a permanent address as of the dawn of the hurricane. So we're allowing people to move around before and after the storm, and we're keeping their treatment intensity fixed. And that's important because it means we're following the same individual student debt over time. So irrespective of whether she moves out of Houston or what school she attends inside or out of Houston. And we're going to split this variable into terciles. And we're really going to focus in on the top tercile of flooded blocks. So severely flooded areas. Why is that? Well, because there could be unobserved threshold effects in flood damage. So for example, a car could be completely unaffected by 6 inches of flooding, but it could be completely destroyed by 12 inches of flooding. So we want to focus on the areas that are most flooded. Plus, we have some measurement error here. We're not seeing the exact amount of flooding that happened at the individual's address. We're seeing the weighted average flood depth that happened at the individual census block. So in some cases, people may be in a severely flooded block, but they were lucky and they just barely escaped the flooding. So we have some measurement error here, which is why we want to focus on the more severely flooded areas and compare them with the areas that did not flood. So we're going to focus on the post-hurricane change. This beta here is post-hurricane change in blocks with top tercile flooding relative to the post-hurricane change in blocks that did not flood. Now in the paper, we show that flooded areas of Houston were fairly similar to areas that did not flood. If anything, they were slightly wealthier. And the flooding was about as quasi-random as we can get. Only about 7% of the variation in flooding across Houston census blocks could be explained by predetermined factors like distance to streams, credit scores, etc. Okay. So I would say this is kind of the main result in the paper. Here, we're plotting the extensive margin probability of having student debt among people with different ages. So the probability of having any student debt, it's a binary outcome. And what we see is on average over the 10 quarters after Harvey, college-aged adults from the top tercile flooded areas are about 2.5 percentage points less likely to have a student loan than their counterparts from the parts of Houston that did not flood. 2.5 percentage points is going to be about 6% of the share of the college-age sample that has any student debt. So 43% has any student debt, 2.5% percentage points would be about 6% of that. And at the same time, there's very little effect of being heavily flooded on the probability that older Houstonians have any student debt. Now that summarizes the top row. The second row is a bit different. Here we're particularly interested in the probability of first opening a student debt account. And that's because when you first open a student debt account, it could be indicative of you starting college. And so we're going to apply a slightly different variation on our method. It's called a discrete time hazard model. And basically all we're doing here is limiting the sample to people who did not have any student debt as of the dawn of the hurricane. And we've also, and we're also doing this because we want to drop people after they first open a student debt account, because student debt is kind of a quasi-absorbing state. Once you have it, you're going to have it for a while. So we want to drop you from the sample after you first open. That should reduce some bias. And when we do this, we find that the vast majority of this extensive margin effect in the top row is owed to these college students who did not, or these college-age students who did not have student debt before Harvey. These are the ones that become much less likely to open student debt after their permanent address is exposed to flooding. The results seem to persist for 10 full quarters, so until the end of 2019, which is the end of our sample. And that suggests that there's no immediate reversion to the pre-hurricane investment behaviors. I'm not showing it here, but these effects are only significant outside the floodplain. We do not find significant effects when we look inside the floodplain, where people are more likely to have flood insurance. Okay. What this is basically showing is just a couple things. It's just a table version of kind of what you just saw. And the first thing I want to highlight is that the effects are monotonically increasing in flood depth. So the more your area floods, the less your probability of opening a student loan account. And we also find some heterogeneity by income and housing status. So we find a significantly more negative treatment hazard in the parts of Houston that are high owner occupied and lower income. So for example, right here, you can see the effect of being in a high owner occupied area, and that is also lower income, basically it nearly doubles. Okay, so we looked at the probability of having any student loans, but what about people who had already taken out some loans before the hurricane, what happens to their balances? So this is the intensive margin. So we're looking at the change in student debt balances in dollars for these people who already had some debt, and we're comparing people in heavily flooded areas to places that did not flood. And you can see for the college age sample, there is a relative decline, but it's statistically significant only when we zoom in on being outside of the floodplain. For these folks, their balances are about $1,000 less when they're in a heavily flooded area relative to an area that did not flood. $1,000 is about 6% of the average student loan balance for this sample, which is about a little under $18,000. So we see this for the college age folks, but for the oldest groups, we don't see much effect. We see maybe a temporary, a fleeting increase in student loan balances, which could just reflect payment forbearance, so accrual of interest on balances during 90-day forbearance. All treatment effects are, again, statistically insignificant inside the floodplain. Okay, so our finding of reduced student debt account openings is consistent with channels that would also predict less higher education attainment, right? So that's what we're going to test for next. We're going to validate that that is part of the mechanism here. We're going to do this using data from the state of Texas. Texas tracks higher education data in pretty granular detail. So we have 110 public universities and community colleges spanning spring 2014 through fall 2019. And we're going to use as treatment a school's pre-Harvey enrollment share from the 40 counties, those counties in red we saw a little bit ago, that were most damaged by Harvey. And we'll basically give all the schools a percentile rank. So a higher rank means the school is more exposed than other schools to students from counties in disaster-affected parts of Texas. There are a lot of schools that draw a lot of students from within those counties that are not themselves located in those counties. So UT Austin, Midland College are examples of that. And we're going to study school level outcomes, so enrollment, graduation rates, time to degree. And basically the beta here is going to be the post-hurricane effect of being in a school with a larger relative to a smaller share of students from disaster-affected counties. And we're also going to look at some heterogeneity in enrollment within schools across different majors. So the high-level result here is that on average, over the 5 semesters after Harvey, enrollment is 3.3, it declines 13.3% at the most exposed school relative to the least exposed school. That's about 3.6% if we split schools at the median of their enrollment exposure. 3.6% schools for above median relative to below median enrollment exposed schools, interestingly, is kind of on par with the effect that COVID had in fall of 2020. So if we look at public colleges and universities nationally, they recorded about a 4% enrollment decline, driven predominantly by first-time students. And this is remarkably similar to what we find after Harvey for comparing schools that were above median relative to below median enrollment exposed to Harvey's flooding. And we find this effect in COVID, despite the fact that during COVID, there were federal student relief grants that were not available during Harvey. And I'll talk a little bit more about that at the very end. And then we also find a modest drop in the graduation rate. But we don't find we don't find a substantial increase in time to degree, which put together would suggest that there may be some dropouts going on as well. So one thing we wanted to look at is how students might be changing their educational investment. Those that keep going to school, is there any evidence that they're switching majors? And we do find a lot of evidence to that effect. So what this figure is showing you is same kind of difference in difference framework, but instead of a regression, I'm just actually showing you the data. So the bars here represent the post minus pre-period change in average enrollment share by major category for schools that had high treatment relative to schools that had low treatment in terms of their enrollment exposure to the disaster. And so because I can't really list hundreds of majors on one graph, I'm grouping majors together. So a major in finance and a major in tourism, they're both part of the business school, for example. And the majors are ordered according to 10-year earnings. So the median earnings that you would earn if you got this major 10 years later. And we put undeclared at the very top since there is no actual earnings associated with undeclared. And what we find is this kind of diagonal pattern with students in high treatment schools leaving undeclared status, as well as low earnings majors like communications tech support, liberal arts, and languages. So for example, the liberal arts CIP group there, the liberal arts major group there, loses nearly 5% more of its enrollment when it's at a high treatment school relative to a low treatment school after the disaster. Meanwhile, you see the majors at the bottom though, there, so majors with higher 10-year median earnings. So these are majors like biological sciences, business, engineering. These are tending to become a larger share of school enrollment in high treatment schools after the disaster. And we find this both compared to low treatment schools and within, if we only look within high treatment schools before and after the disaster, we also see this diagonal pattern. Okay, so let me wrap up on what this all means. So I think stepping back and looking at prior work would suggest that this kind of housing wealth shock should lead to an increase in student indebtedness. But we find that that's not the case for disasters. Surprisingly, leverage actually falls. And while that kind of, at first glance, that kind of seems like positive news for households confronting climate change risk, it's actually kind of concerning because these leverage reductions are likely to be driven not just by less need for student loans, but by less investment in education. So we see this reduction in enrollment and evidence of less continuation. And so I think the one thing we can say is it looks like climate change is unlikely to directly exacerbate the student loan crisis in the US. But the net long-term social welfare consequences of this are really unresolved. So on the one hand, you have less use of student debt, which comes at the cost of less higher education investment. That's problematic because it could lead to brain drain in disaster-prone areas. It could exacerbate inequality to the extent that getting an education helps combat inequality. But on the other hand, we see more enrollment in high earnings majors, which could end up boosting aggregate productivity. But even if the aggregate effects are positive, the distributional consequences across students could still be problematic. So I think we can also say that current policy tools don't appear to be mitigating the effect of these disasters on schooling decisions. And that's best evidenced by this proliferation of emergency student relief programs that occurred during the COVID-19 pandemic. So if you recall, lots of schools got money from the federal government and they were assigned to allocate some of those funds to students in need in the form of relief grants. And part of the reason that had to happen was that our FAFSA forms, the forms you fill out to qualify for aid, they don't adapt very quickly to wealth and income shocks. So your FAFSA is based on your family contribution from the 2 tax years prior. So they're not immediately adapting. And so I think we need to think about how to adapt student aid, how to adapt disaster aid to the needs of students. Or this paper suggests that we might face the consequences of reduced educational investment in the wake of these disasters. So on that very happy note, the end.
You're able to hear me, right?
Yes.
Okay, great. I think we have time for a couple minutes of questions. So there was a question in the Q&A box from Olasola Auditoro asking, could you please, how did you integrate other factors apart from flood to the causes of dropout, increased debt, and student performance? Don't you think other factors could be inclusive and flood only aggravating the challenge?
Yeah, so I think one of the unique features of Hurricane Harvey is that it didn't have very negative effects on the labor market. So a natural other factor is like your work floods. Your parents, for example, can't get to work; they can't earn income, and so it's not that your house flooded, but maybe you can't work, for example, that causes you to drop out or something like that. Now, Hurricane Harvey was a bit unique in that there weren't major labor market effects. That's different from Hurricane Katrina. New Orleans was very dependent on their port and on their tourism industry. Houston has a much more diversified economy, and when you look at labor market effects, the labor market actually did fine in the aftermath. Not only that, but we're comparing people within the city of Houston. So if you can assume that people in the flooded parts had access to the same set of jobs as people in the not flooded parts, then that sort of effect should not be influencing our results. I do think there is the possibility that some people had to stay home to help their family, but that would again be linked to the actual flooding. I'm not sure if that, I hope that answers your question.
I think so. Thank you. Very nice presentation. I think we're about exhausted all the time for that first presentation, so we should move on to the second presentation. So this is by Jonathan Colmer of the University of Virginia. Jonathan, you can take over as soon as you're ready.
Wonderful. I think hopefully you can all hear me and see me. Daniel, can you see and hear me? Daniel's gone. Okay, I'm just going to go for it. Great. Well, it's great to be here. I'm very much looking forward to these events being back in person. But in the meantime, it's wonderful that we have an opportunity to meet online and hear about the research that's been going on in this space. So I'm Jonathan Colmer, an assistant professor at the University of Virginia, and I'm director of the Environmental Inequality Lab. And this is this paper is part of a broader research agenda that I've been working on over the last few years with the US Census Bureau, John Voorhees, particularly the US Census Bureau, on trying to understand the distributional consequences of environmental risk. So thinking about who is more vulnerable to environmental risk, broadly defined, and how the consequences of environmental shocks are distributed across individuals in society, and sort of how policy and interventions that try to reduce environmental risk disproportionately affect different groups. And this paper is part of this research agenda, but is related to another project more specifically that we've been working on the distributional effects of hurricanes in the United States. And so there's some of you may have seen that paper at various conferences that we've been presenting at. If you're in the academic space, and if you're not in the academic space, if you're a policymaker, then it's great to have the opportunity here to tell you about what we've been up to. So in this paper, we're really interested in trying to understand the role of learning and information in the context of adaptation. Let me see if the slides click. Oh yeah, here we go. So this is the paper. Are you experienced learning and adaptation to hurricanes in the United States? And this is joint work, as I say, with John Voorhees, who's my research partner at the US Census Bureau, and Brennan Williams, who is a graduate student at the University of Virginia, who will be on the academic job market this year and has a terrific paper on the effects of prenatal exposure to hurricanes in the United States and the long-run effects on earnings and economic mobility, and particularly the role of he also looks at the role of forecasts in mitigating damages. So it's keep an eye out for that one. That will be coming out very soon. So, as I said, the focus of this project is really thinking about the role that information plays in decision making. And, as has long been argued by economists, perfect information is essential for decision making, for optimizing behavior and for markets to work efficiently. But the elephant in the room, of course, is that this assumption very, very rarely holds. And in fact, the people have different access to information. They trust information differently. They process and respond to information differently. And so the assumption of perfect information or rational response to information is I would say deeply flawed, and most economists, I think, would not be sort of don't seriously hang their hat on this. It's a useful starting point for our undergraduate models, but it's not how we think the world works. And the question that the question we're particularly interested in, at least so far in this project, I would say this is a new project where we're still working on it. It's in progress. The question we're wanting to ask today is whether people learn from experience. We can think there's two ways of learning, broadly defined: learning from others and learning by doing, or learning by experience. And so we're particularly interested in this context in learning, in trying to understand whether people learn from experience, and particularly whether experience of previous hurricane events affects how a later event affects your economic damages. And the context of looking at this question in the context of using hurricanes to look at this question, we think is quite nice, because measuring or identifying the effects of experience is incredibly difficult normally. Going back to a very old literature by the Nobel Prize winner Jim Heckman, this issue of measuring the effects of experience is incredibly challenging, because normally, if people are exposed to multiple shocks and those shocks are serially correlated, it becomes very difficult to disentangle the effects of experience from what we would call unobserved heterogeneity, or just something to do with the individual's ability to manage or respond to shocks, which means that they are more likely to be exposed to more shocks in the future. So, if people, I think it's safe to say that for the most part, people are pretty familiar in terms of their own willingness to accept risk and their ability to self-protect. That's not something that as researchers we observe in the data. And if we think that people who have a particular edge dealing with shocks are more likely to be exposed again, because they are less likely to move away or select out, then these experience effects might be not really capturing experience, but rather capturing differences in individuals. And so what we would normally be calling a differential response due to experience might actually just be a differential response due to just measuring different types of people in the sample. Now, most of the evidence, because of these issues, most of the evidence on learning from experience has come from experimental settings where you can do controlled lab experiments to try and measure experience effects. So there's less evidence on experience in real world settings, and much of the literature on experience is trying to grapple with these issues of separating experience from differences in types of people. What we think is quite nice about the context of hurricanes is that hurricane shocks themselves aren't serially correlated. It's for all intents and purposes, I think all of the papers today are using physical measures of hurricane exposure, not damages or other factors which are going to be correlated with economic or political conditions, but these truly climatological factors that determine hurricane exposure. And so for all intents and purposes, whether you're exposed to a hurricane or not is conditional on where you live, is going to be as good as random. And I'll get into the details of the empirical controls that we have to allow for this conditional exogeneity, which is this this assumption that we're going to be relying on. And because of this lack of serial correlation, being exposed once doesn't increase your likelihood of being exposed again. And because exposure is relatively infrequent, we have this context in which we can trace out experience over time and look at the degree to which that actually affects or affects the translation of future shocks into damages. So hopefully I've got a crying child in the background, hopefully, and that's not coming up over the microphone. Apologies about that. So in this project, what we're going to do is we combine spatially very granular data on individual level exposure to hurricanes with tax and demographic data. And so what we have is effectively 25 years of individuals being able to follow individuals over time and space. We have information on residential histories, so we're able to not just sort of see, which county or state they're living in, but which house they're living in. We know the characteristics of the house from residential data, which is linked in with this. And so we can follow people's migration and return migration if that's what's going on, as well as sort of their earnings, demographics, and other considerations, transfers, etc. And we're going to use this to sort of introduce what we think are some new facts about the role of experience in managing or adapting to hurricanes in the United States, as well as shedding light on the degree to which people are potentially under investing in self-protection. I think there are some interesting questions here which we've not got at yet about what that implies for public versus private adaptation responses. We're not going to be able to speak to that today, but I think what we're going to show, spoiler alert, is evidence that experience does dampen the effects of hurricanes. And so that opens up some interesting questions going forwards. So there are sort of going to be three parts to the paper. The first one is going to be some sort of new, just descriptive facts about sort of who is exposed to hurricanes in the United States, given that we have this incredibly rich individual level data, which is population wide, and who experiences more hurricanes than others. Just this is all in the cross section, and how this has evolved, like how exposure to hurricane risk has evolved over time. So these are just descriptive facts, but I think incredibly helpful for trying to better understand the distribution of exposure. Then we're going to move on to trying to understand the effects of being exposed to a hurricane shock, which is different to hurricane risk, which is this equilibrium idea. The shock is this random shock that people weren't expecting, or bar forecasts. And so we're going to look at the effects of hurricane exposure on average in terms of the effects on total income, earnings, and transfers. And then the final part is going to be to look at the role that people's experience over the life cycle has played in terms of affecting this translation of the hurricane exposure into earnings and the other outcomes. So in terms of the data, so the primary sample is going to be the 2000 long form census. So this is going to be a 1 in 6 sample of all US households. And we're going to combine this with the individual level restricted access American Community Survey data from, this should say, sorry, 2005 to 2018. No, it's 2001 to 2018, sorry. And then we're going to link this to administrative tax return data from the IRS, as well as with residential level geo-identifiers. So going back to the early 1990s, we see every time someone moves house. And so that allows us to trace people over time and space. And then so when we put all this together, what we have is this 25-year long panel of people's earnings, transfers, and migration history, as well as rich demographic information on race, education, sex, age, all of those sort of information and details that you get from the census as well. We're going to impose a couple of sample restrictions. Unlike the previous presentation, Emily's presentation, which did a really great job of providing detailed information on the effects of a particular hurricane, Hurricane Harvey, we're interested in providing systematic evidence on all hurricanes in the United States. And so because of that, what we're going to be, instead of just sort of using the whole of the United States, we want to focus in on sort of areas that are maybe a bit more bit better in terms of a suitable counterfactual. So we're going to focus on the 21 hurricane states, which is increasingly common in the exercises where you're not just looking at Hurricane Katrina or Hurricane Harvey. And above and beyond that, we're going to focus specifically on coastal counties defined by NOAA in these hurricane states. And the reason for doing this is there's a number of reasons, but hurricanes obviously are these multifaceted things. We're going to be focusing on physical exposures of hurricanes based on wind speed and maximum wind speed, which I believe the next presentation is going to focus on as well. But as Emily's already told us, hurricanes also cause floods. And so what we don't want to do is sort of use non-coastal counties, which could be affected by flooding through storm surge, but have sort of no real extreme winds as a control group for our highly affected high wind situations. And so we're going to be focusing on coastal counties, those who are exposed to high winds versus those that were not. So that's sort of our baseline sample. We then combine this with census tract year level measures of maximum sustained wind speed. So we do this using what is now relatively standard within the hurricanes literature, which is to basically use physical measures of hurricanes as opposed to damages, which we know are not exogenous. They're correlated with economic and political considerations, and so you're not identifying the effects of hurricanes. You're identifying some weird, combination of a bunch of stuff, hurricanes plus economic conditions. Instead, we know from environmental science that hurricanes, in terms of their generation and where they actually finally end up going, are as good as random. How sort of rich or poor a neighborhood is does not affect the path of the hurricane. And so we're going to use 6 hourly storm track data from IBTrax, or HERDAT is the same data. IBTrax is the global database. HERDAT is the US version. And then we're going to apply what we're calling a structural wind field model, which is a physical model of how wind is sort of distributed from hurricanes away from the track. And this allows us to sort of get a broader sense of hurricane exposure. And Sol Shang and others sort of, Sol particularly, I feel that, it really introduced this approach within the economics literature of modeling hurricanes in this way. And so we're following in his footsteps, as well as others who have continued in this path. So as I mentioned, the benefit of this is it avoids on relying on these endogenous measures of hurricanes. So we can be pretty sure that what we're capturing is exposure to hurricane winds as opposed to something else. And we're going to say that an individual is exposed to a hurricane in a given year if they're living in a census tract that experiences maximum sustained winds exceeding 50 miles per hour, which is the cutoff for dangerous winds from a hurricane. It's not hurricane force winds, but it's a cutoff for dangerous winds according to NOAA. And then we're going to define experience as the number of individual level hurricane exposures that you have had to date. And that's so when you experience a hurricane, then the following year you have, if it's your first hurricane in T-1, you had 0 hurricane experiences. You get hit by a hurricane, and then in T+1, you now have 1 experience. So this is just a nice, pretty map of the distribution of census tract level exposures in coastal counties between 95 and 2018. And we see, that there's a lot of variation in intensity across the coasts, along the coasts, and this is just sort of the average. And so in a given year, some places are affected, some places aren't. It's, again, the argument is that it's as good as random. So starting with some sort of stylized facts, what we're going to do first is proxy for what we're calling equilibrium hurricane risk. So the propensity that, a location is hit by a hurricane, by using a location's average exposure between 1980 and 2019. So this is independent of our individual level data to begin with. We're just defining this sort of location-specific measure of risk. And then we're going to see how that equilibrium level measure of risk, which is in the cross-section, is correlated with individual characteristics, as well as how it how average risk has evolved over time in the United States and in these coastal counties. And what's nice about the time series dimension here is that any variation is driven entirely by migration because of the individual level migration things that we see. So when we collapse the data into the time series, if we see a decrease in risk over time, that tells us that people are moving away from hurricane-prone areas. If we see an increase in risk over time, it's telling us that people are moving towards, and if it's flat, then we see that there's no sort of systematic movement away or towards hurricane risky areas over time. And then, for each individual as well, we want to know stylized facts about experience, who is exposed to more versus less hurricanes. So again, we're just going to provide descriptive correlations along those lines. So starting with the time series, we see that whether we look at the entire US or coastal counties in hurricane states, there doesn't appear to be any systematic movement towards or away from riskier areas over time. There is a difference in average risk exposure in the US as a whole. Obviously, we're including a lot of places that just never get exposed to hurricanes, and so average risk is much lower than it is in the coastal counties of hurricane states. But this has remained pretty flat over time. So there's no sort of systematic sort of equilibrium response to hurricane risk. People are not moving away or towards sort of hurricane risk over time, it seems. We can do this by income. We can do this by race. We see that, as you'll see in the next plot, that if you're Black and Hispanic or non-Hispanic Black and Hispanic, you're exposed to higher risk, but again, flat over time than if you're white or non-Hispanic white, sorry. And if you are richer, you're exposed to sort of slightly lower levels of risk, but not in a meaningful way. So if we then go away from sort of the time variation to just to say, okay, in the cross section, in an equilibrium sense, who is exposed to more versus less risk? We see that non-Hispanic, whether you look in the US as a whole or in coastal counties of hurricane states, if you're non-Hispanic Black, you're much more likely to be exposed to a hurricane in terms of risk. You're not more exposed to a hurricane, but you're exposed to greater hurricane risk. Sorry, I've got to be precise here. In the US as a whole, you're about 25% more likely to be exposed. 25%, you're exposed to 25% greater risk effectively. If you're in coastal counties, you're more than twice as likely to be living in a risky area. I think that's probably the best way of putting it. If you're non-Hispanic Black. And so this sort of gets into, the effect of being hit by a shock is as good as random, but some people are exposed to greater risk than others. So yeah, if you're less educated and if you're non-Hispanic Black, then you are exposed to greater risk than otherwise. In terms of variation in hurricane experience, so this is in terms of the number of hurricanes that you're exposed to, we see some differences here. If anything, we see that older individuals and more educated individuals have experienced more hurricanes. Now, the age thing, of course, is totally mechanical. If you are older, then you will have had more of an opportunity to be exposed to more hurricanes. But the education margin is interesting. And anyway, this is again an equilibrium point. So this is not causal. These are just correlates, and we're not saying this isn't an issue in terms of when it comes to trying to identify the effects of hurricane exposure, because as I said, the hurricane doesn't say, oh, you're more educated, therefore I'm coming for you. It's as good as random in terms of the shock of a hurricane. So in terms of trying to estimate we want to estimate the dynamic effects of these hurricanes. These are sort of shocks that turn on, and then we want to understand whether there is sort of a persistent effect, or whether there's a return to trend, or build back better, or whether there's just no effect, or whether there's a lagged effect. And so we don't want to just focus on the immediate effect. We want to kind of understand how things evolve over time. And this is, in terms of the econometrics, incredibly difficult to do. in Emily's context, she was looking at one shock, and differences in that situation work reasonably well. And that works well. That's worked well previously for looking at Hurricane Katrina and other considerations. But when we're working in this context of looking at multiple shocks that are staggered and are potentially repeating, it becomes a bit trickier. And so differences, then it doesn't necessarily work. And so we're actually going to rely or draw from the literature in macroeconomics. And macroeconomists have thought, I feel, have spent a lot more time thinking deeply about dynamic responses to shocks. They're incredibly sort of thoughtful in terms of the measurements and consideration of dynamic effects. And so we're going to sort of the initial sort of work on this this estimator we're using is this local projections approach by Jordan in 2005, which I think has been cited like 1,500 times now. It's crazy. The idea behind the Jordan approach is that if you want to get at dynamic effects, it's better to try and get a local approximation of each horizon rather than using a model which basically approximates the global response. And so what we're going to do is for each time horizon, we're going to estimate a separate regression, and that tells us the effect at horizon H. And recent work by Rambuchan and Shepard and Bojanov et al. Basically say that, we're not having to, as long as you're happy with the assumption of conditional independence, which is a stronger assumption than the differences setting of assuming common trends and things like that, then we're good. Am I running on time, Daniel?
Jonathan, yeah, you do need to wrap up as soon as you can.
I've got a few more slides.
It's Q&A time now.
We'll be done very quickly.
Okay, thank you.
So the conditional independence assumption is a stronger assumption than the differences literature. But what's quite nice about the context of hurricanes is that assumption is a lot more reasonable than, say, in other contexts where macroeconomics is maybe using these estimators. So let's see what we see. So these are the results on average. The effect on total income is somewhat muted. It's significant, but very small. This is consistent with, I think, our understanding of the literature to date in other contexts and the work that people like Tatiana Derogina and others have done. The effects on earnings is bigger, but then again, there's this sort of recovery in the sort of medium run. And then the effects on transfers, which is sort of what's offsetting this earnings effects, again, is this big increase and then a sort of a return to trend within a few years. What about the effects of experience? So what we see is that for every individual storm that you experience, the effect becomes more and more muted. So the effect on total income was already quite muted, but if you have no experience, we see a larger effect on total income, and that's earnings net of transfers. Looking at the earnings effect as well, we see much bigger effects for those that have had no experience, and then it becomes more muted over time. And then with transfers, there's less of an effect, a bit of a weird kink here, but these things I don't think are different statistically. So yeah, this is what we have. This is what we have so far. We're trying to learn a little bit more about what's going on here, but this is how things stand. So just to wrap up, we traditionally think of adaptation as this sort of equilibrium outcome of private and public decision making. Some people are better protected than others. And so, we're making equilibrium investments where marginal private benefits equals to marginal private costs for private investments, and for public investments, we're equalizing marginal social benefits against social costs. And what our results are suggesting actually is that, individuals might actually be underinvesting in private self-protection, and that they really only sort of realize the benefits or learn the benefits of investments once they have had that experience. And so defensive investments in this respect might be experience goods. Unclear what this implies for public investments, but that's where we're going to try and think about this a little bit more. So thank you very much.
All right, great. Thank you, Jonathan. I think we have one question, which we can take now, and then we'll move on to Alessandro.
Great, thank you.
So the question from Stephen Mack is, people may be living in a particular census tract, but have no direct experience of the hurricane itself because of advanced warning and let them evacuate before it hit. Your data includes tract level data. ACS is only good for that in large cities, but how is that related to individual household housing experience is not clear. Could you please explain better how you go from grouped aggregated data to assume individual risk measures?
So we're using individual data, not grouped data. The ACS, the public ACS, is not very good at the tract level, but the confidential census level data is individual. And so it could be the case. Here is a story that if you have more experience, you know to evacuate, and so then maybe you have you're more the effect in terms of the shock is less for you. That's possibly an underlying mechanism. It's not an issue in terms of identification, but yeah, we're not going to see that immediate sort of very short run migration response, but we do see sort of longer run responses. But yeah, we're using individual level data, and we know individuals at the household level. We know what their exact address is within, so we go to the census tract just because that seems like a reasonable level of a measure for sort of thinking about wind speeds, given how correlated things are. And then your total income, it's the total income for that year. It's your tax return. So it's your 1040.
Okay, great. That makes sense. Thank you. So in the interest of time, I think we'll go ahead and move on to the last presentation by Alessandro Barattieri. So Alessandro.
You guys hear me? Do you hear me and listen to me?
Hear you.
Wonderful.
And see you.
Perfect. So thank you very, very much to the center for this wonderful symposium. Thank you to all of you for being here. My name is Alessandro. Today I will present to you very quickly this short paper, which is called The Short-Run Dynamic Employment Effects of Natural Disasters, New Insights. Very heterogeneous team for this paper. So my teammates are Pratis Borda from the University of Antibes, Alberto Brugnoli from the University of Bergamo, and the two adults in the room are Martino Pelli from the University of Sherbrooke and Jean Chop from the University of Bern, who are actually the environmental economists on board. Perfect continuity with the previous paper, so Jonathan did an amazing job, so my job will be much easier. So hardly difficult to motivate the paper in this context. So, we all know the importance of studying the effects of natural disasters, and this has become a central research question in several fields in economics. However, it's fair to say that especially in, I should say more cautiously, developing jurisdictions, due to data limitation, there is a certain scarcity of evidence using high frequency and detailed industry data. So this paper provides a very, very simple idea, which is a natural laboratory. And this laboratory is Puerto Rico. So what we do is to study the employment effect of natural disaster using the experience of Puerto Rico, which has a unique feature. The combination of a frequent exposure to natural disasters combined with the availability of high-frequency detailed employment data from the BLS, because Puerto Rico is part of the US. So by doing this, we, who are also macroeconomists, provide the first estimate of the short-run dynamic disaggregate employment effect of natural disasters. We use a panel local projections, which were just discussed, using monthly data for over 93 three-digit NAICS industries and 78 counties over the period 1995 to 2017. We also use an exogenous measure of exposure to intensity of disaster based on satellite data and wind speed. What do we find? Three main things. So first, disaster shocks cause on average a temporary decrease in employment and wages of up to 1%. The effects peak at 6 months and disappear within 2 years. Secondly, and perhaps most interestingly, we do find extreme heterogeneity in the responses to natural disaster across industries. In particular, we want to present you with 3 groups of industries. One industry, which we call the strengthened industries, not surprising, the construction of building, special contractors, but also, for instance, furniture stores, which actually experience an increase in employment following a natural disaster. Then we'll present you with the weakened industry, again, not surprisingly, perhaps, accommodation, retail, but also printing activities that seem to experience a decline in employment following natural disasters. And finally, we find some industries which we call neutral, in which employment doesn't seem to be affected. The third point we want to make is that input-output linkages are likely mechanisms that can explain some of these results, some of which instead we believe are self-evident. There is a lot of literature on of course, and here I'm no expert, so you know better than I do, but to us, this idea of combining short-run monthly data with satellite exposure in terms of wind speed seemed new. So in what follows, I will first speak briefly about the measurement of disaster shocks, then our empirical strategy, and then the results, and especially the conclusions, which will have a sort of positive tone, given their question of climate change. So how do we measure the disaster shocks? Here I would play the Rocky song, usually the Eye of the Tiger, but you know we have been enough exposed by now to these topics to understand that it's important to use measures which are not damage related, so that are in fact linked to geographical geophysical features, and in particular, knowing the position of the eye of the storm can be used to obtain wind speed in all areas around it. And so essentially what we do, as the previous paper did, we use best track data from which we can have longitude and latitude of the eye of the storm and the wind speed around it. We interpolate it, so we have a path for every kilometer of the hurricane, and then we can compute essentially the distance of the eye with each county's weighted centroid, where we use block population from the census data. And then we can use the hurricane model, which is a terribly complicated formula, to compute the wind speed at each county for each hurricane. Once we have this information for each storm or hurricane, we can retain the maximum wind speed to which a county C was exposed. And now we can combine these to get a measure of exposure to disasters, one of many that we use. In the paper, we propose a lot of robustness, but the one that I'm proposing you today is a county level storm exposure measure, where basically we take only those episodes where the wind speed were above 33, which is defining a tropical storm. And then we essentially cube that. And the reason why we take the cube of that is that by law of physics, the cube of wind speeds express the force exerted on built structures. And then we take an average relative to the maximum of the sample. So one picture is 1,000 words. So I'll give you 2,000 words because I show you two pictures of what we have. So we have more than 20 hurricanes hit in Puerto Rico. And we have extreme heterogeneity in terms of how the different counties of Puerto Rico have been hit by these disasters. So in particular, for instance, Hurricane George, who hit Puerto Rico in September 98, was mostly hitting the center-north part of the island. In particular, Catano and Toa Alta are the counties most affected, whereas Jeanne, for instance, had hit much more the western part of the island, and Aguada and Cabo Rojo are the counties most affected. Irene and Maria, on the other hand, hit most heavily the eastern part of the island, and so Culebra, for instance, is a wonderful place, by the way, for those of you who went, which was heavily hit by the storm. So, having said that, we do have this extreme heterogeneity in exposure for Puerto Rico's counties over time. And we combine this with detailed employment data from the BLS. So essentially using the same tool that has been explained in the presentation before, the panel local projections, so which I will just briefly review them here. Essentially, the idea is that you run a series of k-step ahead panel predictive regressions. So you have a variable of interest, which for us will be the cumulative change either in employment, measured at monthly level, or in average weekly wage, measured at quarterly level, which you regress on our measure of exposure to disasters. And then, so the gamma k are the impulse, the coefficient of interest are actually what they are tracing the dynamic response of this variable of interest to the disaster shock. Because we have such an extreme richness of data, we can obviously include fixed effect for time, for industry, and for geography. A second part, instead, of the analysis will be at the industry level. And so for now, each industry will run a local projection where we'll aggregate in population-weighted averages our county level measures. So we'll have a industry-wide, island-wide measure of exposure to natural disaster, and we'll use that to gauge the impact of these natural disasters on the employment and average weekly wage of each single industry I. in that case, we will not explore all the county level heterogeneity. We will control, therefore, for aggregate dynamics with an equivalent of the aggregate variables, so either employment or wages, and we will control for seasonal effects. So what do we find? So here I'll present you a mix of main results and robustness. So in the panel local projections, what we find is that we have, as you can see from the left-hand side of this panel, a reduction, an average reduction in employment for the average hurricane. So clearly, once you run this local projection, then you need to decide the size of the shock that you are showing in terms of the response. And this is actually the average hurricane hitting Puerto Rico over the period. And so again, this is just a sequence of the coefficient from each different horizon regression with its own bootstrapped standard error. So what you can see is that you do have this decline in employment when you consider separately the geographic time and industry fixed effect, and a decline in average weekly wage, which is borderline significant. Because, again, of the richness of our data, we can combine fixed effect, and so we can explore more demanding specification, where instead of having these fixed effects separately, we have interactions of them. So in particular, what happens if you now combine geography and industry fixed effect, you have a very similar picture. And the same thing happens if you basically instead interact industry time fixed effect. Of course, the third possibility you cannot do, because the shock varies at the level of time and geography, so that fixed effect would capture up all the variation that we're interested in. A fourth and important specification, which I didn't speak of, but perhaps some of you might be interested in, is a specification where we go to census data, and we actually take also the at least yearly dynamics of population by county in Puerto Rico. And so this limits our sample to after 2010, but we think it's very important to have this specification, which somehow can partly control for movement in labor supply. And so essentially this is what we find if we now add as a control also the county change in population. And as you can see, if anything, this is even a little bit more significant than before. Okay, so these are main results. And then we move to the industry level results. So as I said, 3 groups of industries here. The beauty is I hope it's not too small. For me, it's very small, but I hope that you guys see it much bigger than I do on my screen. So on the first panel, you see something obvious, the construction boom, right? And you could see that, you can read the paper, but it's also in wages. You do observe an increasing wage. This is, I think it's important. Then you see that some manufacturing industry experience an increase in employment following these natural disaster shocks, in particular fabricated metal product manufacturing or furniture product manufacturing. As you can see, interestingly, with this initial bump and then an increase forward. And finally, there are also some service sectors which experience an increase in employment following the disaster shock. And particularly, you can see furniture and home furniture stores, building material and garden supply stores, and finally, less clearly, administrative and support services. So these are the strengthened industries. What we call the weakened industries instead are the ones that experience a negative employment effect, in the short term at least. And here we do see crop production and animal production and agriculture. We only see one actually manufacturing sector experiencing this decline, which is printing and related support services. We'll discuss that later. And then we have essentially stores, and this is also very, very reasonable, and even more so, all that is linked to accommodation. So for instance, food services, accommodation services, even precisely scenic and sightseeing transportation services. So last but not least, What we call neutral industries are actually the bulk of the manufacturing industry in Puerto Rico. So how can we discuss this? Well, these results, let me say, are very robust in the sense that we use in the paper a variety of different measures, including higher threshold to consider the wind speed, different formulas to compute the wind speed, using geographical centroid of each countries instead of the population-weighted ones, and the picture that emerge is really absolutely consistent with the one that you saw now. How we can discuss these results? Well, some results to us are pretty intuitive. So a disaster shock generates a construction boom, affects negatively retail, transport, accommodation industries. Some other are actually perhaps less evident, but in our view, easily understandable in the light of a precise mechanism, which is input-output linkages. So just by inspection, if you look at the USIO tables, construction sector are in fact the most important buyers of both furniture manufacturing, they absorb about 52% of their total sales, and fabricated metal product manufacturing, they absorb around 26% of their total sales. Retail and accommodation sector are also potentially important buyers of printing activities. Like here, it's a bit speculative because in the aggregate for the US it's 10%. My own idea, I never visited Puerto Rico. I should perhaps, but is that in Puerto Rico it might be more important. But we want to point at this insight that input-output linkages can be important mechanism in the transmission of the employment effect of natural disaster in the short run. And so essentially, I want to spend a little bit more time on the conclusion because we'll have some policy implication that I would like to discuss with you. What we did in this paper, which for the academics is explicitly conceived to be a short paper, so that's why also can be presented very shortly. We studied the short-run employment effect of natural disaster using disaggregated data for Puerto Rico and an exogenous measure of exposure to shocks, akin the one that Jonathan used before. We do find disaster shocks that cause a temporary decrease in employment and wages, but a lot of heterogeneity across industries. Some results are obvious, some perhaps explained by IO linkages. Now here is where perhaps an interesting discussion with policymakers could arise, because in our own view, the idea that there are different cyclicalities of different industries to the exposure of disaster shock actually lends its hand to the introduction of a potential new concept of resilience to natural disaster shock. We'd like to call this concept adaptability-driven employment resilience. And we want to define this as the potential ability of workers to rapidly reallocate from contracting to the expanding industry in the aftermath of a natural disaster. Now, there's not much research on this, but we did find some papers that in the context of the developing world were saying that one of the major problems after the disaster is precisely the lack of experienced construction workers in order to for the effort of the hotel construction. And so in our own idea, the potential of this adaptability-driven employment resilience could be achieved or perhaps enhanced by introducing new and different vocational training programs. The basic idea would be that if, say, let's take a developing country, if a vocational training program were able to form people both in serving in the accommodation industries, but then the case B, being able also to, at least to a certain level, work in the construction industry, then those people would be more resilient precisely to the event of a natural disaster. So, in the word of an Italian, I'm Italian as you might have understood, an Italian advertisement, prevent is better than cure. And so with this potential positive end note, I would like to thank you all and to invite you to contact me, or especially my colleagues who are more expert than me in these topics, if you have questions, complaints, or if you want more information. I believe I promised to do it in 17 minutes. I'm 30 seconds late, but I think it's okay. Thank you.
All right, great. Thank you, Alessandro. Very nice presentation. We have a couple minutes for questions, and let me see, check the question box. Okay, I'm not seeing any yet. Let me ask a question. So,
yes.
So I'm quite familiar with that, the local projections approach, and one issue with it, I think with panel data in particular, is concerns about pre-trends. And I'm wondering if you think that, like, how we should think about whether there are pre-trends or not. Is it possible that some of the outcomes could have, like employment and wages, could have pre-trends, in the sense that certain areas are more prone to being hit by disaster, and maybe places that are seeing declining employment or declining wages are more prone to disasters for whatever reason? Is that something, do you think, are controlled by the fixed effects, or
there is
not?
a fixed effect? I do believe that, you allowed me to say one thing that I didn't say. So I think Puerto Rico has great aspects and bad aspects. Now, one great aspect of Puerto Rico is precisely that this is probably not true. If you take the United States as a whole, there is the 21 coastal states, right? And so you do have this aspect that you have parts of the state that are consistently hit more by this hurricane than others. Whereas in the picture that I showed you, you can clearly see that that's not the case for a small island like Puerto Rico, where depending on where the hurricane passed by, you have different areas that can be affected more or less. So that's, I guess, a combination of this with the fixed effect could be a part of the answer. Let me though say what I do think is a limit of Puerto Rico. Of course, Puerto Rico is a small island with 600,000 people. So whereas we don't think that the external validity of our result in terms of quantitative results should be taken, very seriously, ourselves we don't. What we hope that this paper could do is to give a qualitative insight, which instead we strongly believe. And these alternative cyclicalities, different cyclicalities of different industries that can actually lead to what I explained at the very end, it's something that I do think we could find. If we had this data, right, for a developing country in Asia or in Africa or in Latin America, I think we would still find this type of results.
Mm-hmm. Okay, thank you. Let's see, so we're at 3:07. I think that we have a little bit of time for discussion among all the speakers. Let's see, Lolly, did you want to add everyone back into the stage? Okay. Let's see, okay. Jonathan and Emily, are you able to
There we
speak?
go.
Okay, good. I see you, I hear you. Let's see, Emily. All right, great. Okay, well, let's see. So Jonathan, Emily, did you have any other things you wanted to say? Or Alessandro, we have a few minutes for questions and any other comments you guys wanted to make.
I really enjoyed both presentations. I could throw one point at each. So Jonathan, I was wondering, if in the last slide, these differences were statistically significant.
Yes, they are. Yes. So I didn't put the confidence intervals up there because it would have been really messy.
Yeah, no, exactly. It's just a matter of presentation. And then we should definitely talk outside of this, because it's incredible that we are doing so similar things. So it's great, I think.
Yeah, the local projections thing, I think, is, and Daniel's done work with local projections as well. I think it's for trying to understand the dynamic effects of disasters, where you don't necessarily want to assume like a permanent effect, which is what you're implicitly coding in differences. Like when you're trying to look at repeat events, like I think there's a lot of hope here, because within the two-way fixed effects literature, it's a total nightmare at the moment. And for doing differences for natural disasters with staggered rollout, it's hard. And so local projections, I think, has some nice properties which require stronger assumptions, but which are totally reasonable in the context of natural disasters. So we don't have to rely on common trends. We can rely on conditional independence, and then that's we don't have to worry about these different complexities.
One thing I'd add that I've thought more and more about is using local projections, which is like Jonathan, you talked about how this is, it's a sort of well-developed methodology in the macro literature. And when you think about macro time series, they usually have a sort of well-behaved time series property, in that if you control for a few lags of, say, your treatment variable, or a few lags of the dependent variable, or ideally both, then you would think, okay, now I've got the treatment variable now is essentially a shock because I've controlled for these lags. When I think about it with disasters, it's harder because disaster that hits this year may very well hit again in 3 years or 4 years, which is going to affect the impulse response function that you estimate. And even controlling for a few lags doesn't necessarily pick that up because it's not a well-behaved time series kind of thing. So I've been thinking about this a lot myself, of whether one wants to control for sort of future disasters when thinking about the impact of a disaster shock this year.
So one of the things that I've been thinking about this, I've been speaking to a lot of applied econometricians, people like Andrew Goodman-Bacon and Brent Calloway and Pedro Santana. And what's quite nice about local projections is how flexible it is, right? Because the shock itself is as good as random, which is is much better than looking at some sort of like fiscal shock or like change in interest rates, which is a little bit more endogenous, say, than a hurricane. But you have these issues of what I think we would call carryover effects, which is that when you have this shock, if then, because it's 0, 1, and then it turns on and turns off again, you could have a situation where someone was shocked 3 years ago, and if there are persistent effects, like they're in your control group for that year. And so it's like, what does that effect mean? Now, the conditional independence assumption means that it's sort of it's attenuated. In a difference in different staggered rollout situation, it's like a total nightmare as to what's going on because of weighting issues. But what's nice with local projections is that you can sort of impose constraints on the sample a little bit more easily, right? You can do things like say, okay, well, I'm going to look at 4 or 5 lags out or horizons out, and I'm going to say that to be in my control group, you can't have been affected last year or the year before or the year before that or the year before that, and I don't want you to be affected tomorrow, the year after, the year after, and the year after. So you can sort of have like a 5-year either side pure control group. It's sort of like the not yet treated or even never treated assumptions that are going into a lot of these different diff things. And it's so easy to implement. And so we've done robustness checks to that, and it works well. So these carryover effects don't seem to be of first order importance. But the nice thing is that the shocks themselves aren't serially correlated, right? So yes, you can get shocked this year and then you get shocked 4 years later, but whether you're shocked 4 years or 7 years or 3 years later or next year is as good as random for all intents and purposes.
And if I may add, then the geographical aspect is important. So if I may make, I was reading now the chat. I think a slight source of confusion is that what I was showing was average weekly wage, which is nothing to do with income in the sense of a Jonathan thing. So for those of people that were discussing, so we were interested in see whether it's like labor demand or supply that was moving. So we didn't look at earnings or income. So that's. Emily, can I just say ask one small thing? Like I'm totally
one
not
last thing, and then I think we need to close it
we have
down.
2 minutes.
Sorry.
But I had the kind of the sense, as a macroeconomist, that some of your results were considering Houston as the world. You see what I'm trying to say? Like there is the aspect of people just going in a different city in Texas, perhaps, or something like that. I don't know if it's at all relevant. I mean, I didn't follow perhaps too quick. Anyway, so just food for thought, and if it's not relevant, just discard it completely.
So I mean, I think Texas is a bit unique in some ways. Like they have a really nice public higher education system, so a lot of people stay in state. But I don't know. We're looking just based on the permanent address of the college student. So like as long as they have a permanent address in the Houston area, we're just following their student debt over time, like regardless of which university they attend. I don't know if it translates to the world. I don't think it would. It certainly wouldn't translate outside of the U.S., where people don't have to take out massive amounts of student debt to go to college.
All right. Well, thank you, everyone. We need to close this out and let people have a little bit of a break before the next 3:30 session. So there's some interesting sessions at 3:30, the effects of temperature on behavior, adaptation at home, consumption, building codes and insurance, quantifying and minimizing water quality impacts, and integrating climate and transportation planning. So thank you to Emily, Alessandro, and Jonathan for great presentations, and thanks to the audience for great questions, and enjoy the rest of the conference. Thank you.
Thanks all.
Bye-bye.
Bye, thank you.